Hi everyone, it's Scott from Math Logos, where we want to think about education through the lens of the Bible. In this lesson, we're going to look at how we convert recurring decimals to fractions. Let's look at our first example. So show that 0.3 recurring is equal to 1/3. It's just worth quickly showing that 0.3 recurring means that this 3-digit goes on forever and ever. And to show that 0.3 recurring is equal to 1/3, we're going to start by saying this. We're going to let x be equal to 0.3 recurring. Not going to write out that many digits. And we're going to use our algebra here to show this. So what we can do is we can say that 10x is equal to 3.3 recurring. And in all of these questions, what we want to do is we want to line up this recurring tail. So you can see that I've lined it up. And what that means is if I subtract these two, the recurring tail, so to speak, will cancel itself out. So I can say that 10x subtract x is equal to 3.3 recurring. Subtract 0.3 recurring. And off to the side, I'll quickly show what that will look like if I do 3.3 recurring and I take away 0.3 recurring. So again, because the tails are lined up, I can just subtract these. 3 subtract 3 is 0. And again, 3 subtract 3 is 0. 3 subtract 0 is 3. So what I can say is that 10x subtract x is equal to 9x. And we've already shown that 3.3 recurring subtract 0.3 recurring is just 3. And then I get this equation. I can divide both sides by 9, and that will leave me with x is equal to 3/9. And if I remember my original question, I have to show that 0.3 recurring is equal to 1/3. So I need to simplify this fraction. 3 and 9 have a common factor of 3. So I'll divide through by 3 on numerator and denominator. So 3 divided by 3 is 1, and 9 divided by 3 is 3. So I've shown that x is equal to 1/3. And if we remember at the beginning, we said that x was our recurring decimal, because we said up here, let x equal 0.33 recurring. My last line could be this: 0.3 recurring is equal to 1/3. Pause the video and give this question a go. Let's run through the answer. Show that 0.7 recurring is equal to 7/9. So we'll always start in the same way. We'll say let x be equal to 0.7 recurring. And because there's only one recurring digit, I'm going to shift everything one place value column so that my recurring tails line up. So 10x is equal to 7.77 recurring. And you can see that our recurring tail is lined up. Sometimes you might need to shift it more place value columns to do that. But in this case, it's just one. My next line is going to be 10x subtract x, and that's equal to 7.7 recurring. Subtract 0.7 recurring. 10x subtract x is 9x, and 7.7 recurring subtract 0.77 recurring is 7. Divide both sides by 9, x is equal to 7/9. My last line is just remembering what I said x was. I said it was 0.7 recurring above. My last line can be this: 0.7 recurring is equal to 7/9. And what you'll notice is there's a bit of a recurring pattern with these. 0.1 recurring is 1/9. 0.2 recurring is 2/9. 0.3 recurring is 3/9, which we simplified to 1/3. But hopefully you can see that recurring pattern. All right, our next example says show that 0.14 recurring, so it's just the 4-digit that's recurring here, is equal to 13/90. So we'll start this in the same way. We'll say let x be equal to 0.14 recurring, so it's just the digit 4 recurring. And because we only have one digit that's recurring, we're only going to need to shift everything one place value column. So 10x is equal to 1.444 recurring, and my tail is lined up at this point. So these are lined up, so I'll be able to subtract them. 10x subtract x is going to be equal to 1.444 recurring, subtract 0.1444 recurring. And off to the side, I'll do a bit of subtraction. So 1.44 recurring, subtract 0.144 recurring. And because these tails are lined up, I can subtract them. 4 subtract 4 is 0, 4 subtract 4 is 0, 4 subtract 1 is 3, and 1 subtract 0 is 1. So my answer is 1.3 to this right-hand side. 10x subtract x is 9x, and like we said, that's equal to 1.3. Now what I want to do here is I want to remove this decimal place, and to do that I'm going to multiply both sides of my equation by 10. So 9x multiplied by 10 is 90x, and 1.3 multiplied by 10 is 13. And then I can divide both sides by 90 to solve for x. X is equal to 13/90. And my last line is just to remember what I said x was. I let x be equal to 0.14 recurring above. So what that means is 0.1, the 4-digit recurring, is equal to 13 over 90. Pause the video and give this one a go. Okay, let's run through it. So show that 0.56 with this digit 6 recurring is equal to 17 over 30. So I'll start the question as I always do. Let x be equal to 0.5666. This digit recurring. Again, only one digit is recurring, so I only need to shift everything one place value column to the left. So 10x is going to be equal to 5.66 recurring. The tail's lined up, so I can subtract. I'll do 10x subtract x, and that's equal to 5.666. Subtract 0.5 with the digit 6 recurring. Quick column subtraction off to the side. I'll just line these up. And I'll line up the 0.566. 6 subtract 6 is 0, 6 subtract 6 is 0, 6 subtract 5 is 1, and 5 subtract 0 is 5. So 5.1 is my answer to the right hand side of this. 10x subtract x is 9x. And again, we want to remove our decimal place, so I'll multiply both sides by 10 to do that. So 9x multiplied by 10 is 90x, and 5.1 multiplied by 10 is 51. Divide both sides by 90, so x is equal to 51 over 90. And I want to show that 0.5 with the 6-digit recurrent is equal to 17 over 30. So I know that I need to simplify this fraction. So I'll divide the numerator and denominator by 3. We do 51 divided by 3 off to the side. Now I know that should give me 17, but let's just check. 3 goes into 5 once with 2 left over, and 3 goes into 21 17 times. So it does indeed. So x is equal to 17 over 90 divided by 3 is 30. So I can just put one last line in, just remembering what x was. Well, we said it was this. So therefore, 0.56 recurring is equal to 1730. And that's my answer. Okay, next example, show that 0.57 recurring is equal to 19 over 33. So both the 5 and the 7 digit are recurring this time. We're going to have to do something slightly different. Let's start in the same way. Let x be equal to 0.57. And because both digits are recurring, it would recur like this, 5, 7, 5, 7. And it would continue in that pattern. Now, if we scale up to 10x, multiply our decimal by 10, that would give us 5.757 and so on. And what you can see is that it's not lined up. So we need to do something a little bit different. If we shift it one place value column to the left again, we can say that 100x is equal to 57.5757. And what you can now see is if we compare our original x to our 100x, that recurring tail is now lined up. Sorry, I can do 100x subtract x, and that's going to be equal to 57.57 ... subtract 0.57 ... Off to the side, I'll show what that column subtraction would look like. So here's my 100x, my 57.5757, and I'll take away 0.5757. As you can see, the tails are now lined up. 7 subtract 7 is 0, 5 subtract 5 is 0, 57 subtract 0 is just 57. So that's what my right-hand side of this equation will be. On my left-hand side, 100x subtract x is going to be 99x. I'll divide both sides by 99. X is going to be equal to 57 divided by 99. And I need to show that this simplifies to 19 over 33. I need to divide by 3 on the numerator and on the denominator. I'll just check that 57 divided by 3 does indeed give me 19. 3 goes into 5 one time, 2 left over, and 3 goes into 27 9 times. What I can say is that 57 divided by 3 is 19, and I know that 99 divided by 3 is 33. So I've shown that 0.57 with both of those digits recurring is equal to 19 over 33. Pause the video and give this question a go. Let's go through it. Show that 0.45 recurring is equal to 5 over 11. So we'll start in the same way. Let x be equal to 0.4545. And because I have 2 digits recurring, I'm actually going to need to shift it 2 place value columns to the left. So 100x would be equal to 45.4545. And those recurring tails line up nicely. I can then do 100x subtract x, and that's going to be equal to 45.4545 dot dot subtract 0.4545 dot dot dot. 100x subtract x is 99x, and 45.4545 dot 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 subtract 0.4545 is 45. Divide both sides by 99, so x is equal to 45 over 99. I know that I need to simplify this fraction, 45 over 99, and I can use the already simplified version of it above. I know that it should simplify to 5 over 11, and that's going to help me to see what my highest common factor is going to be. Well, I know that 11 multiplied by 9 would get me 99, and I know that 5 multiplied by 9 would give me 45. I know that both of these have a factor of 9. I'll divide through by that on the numerator and denominator. 45 divided by 9 is 5, and 99 divided by 9 is 11. So we have shown that our recurring decimal is equal to 5/11ths. If you're finding the video useful so far, we would really appreciate if you could drop a like on the video and subscribe to the channel. It really helps us out. Thank you. Okay, next example. Show that 0.108 with all three of these digits recurring is equal to 4 over 37. It's just worth quickly explaining what this would look like. So because we have the recurring symbol marking the start and the end of our digits, it means that all three of these digits recur. So it would be 108, 108, and that pattern would continue forever. I'm going to start this question in the same way as I always do. Let x be equal to my recurring decimal. I'll just write down a few more just to see. And because I have three digits that are recurring, I'm actually going to need to shift it 3 place value columns to the left. But let's say you'd forgot that. You could try 10x, 100x, 1000x, and see when your tail lines up. So I'll just show you how you could try it if you'd forgot that you need to shift it 3 place value columns. So 10x is going to be 1.08, 108, 1, and so on. So you can see that this tail is not lined up if we went to 10x. And if we go to 100x, well, it would be 10.8, 108, 10, and so on. And it doesn't line up with either of the two above in that case either. So we would need to go to 1000x. So 1000x would be 108.108, 108, and that would continue repeating like that. And if you notice, the 1000x, the long tail at the end, actually lines up with the x tail at the end as well. So we could subtract these two and it would remove that recurring tail. So we'll do 1000x subtract x. That would be equal to 108.108 recurring subtract 0.108 with that long tail recurring. 1000x subtract x is 999x. That is equal to 108. So x is going to be equal to 108 divided by 999. Now, I need to then simplify that fraction. I know that 999 is going to be divisible by 3. So let's start off by dividing both of these by 3. I'll do 108 divided by 3. 3 goes into 10 3 times with 1 left over. 3 goes into 18 6 times. If I divide by 3 on the numerator and denominator, that gives me 36 over 333. And I can continue to simplify. I can divide through by 3 again. So that would be equal to 12 over 111. And at this point, I want to then check for other factors. And to help me do that, I'm going to look at the fraction that it should simplify to. So I know my numerator should, at the end of this, be a 4. And I want to think, how would I go from 12 to 4? Well, I'd need to divide it by 3 again. So we'll take one new line. We'll say x is equal to 12 over 111. And we're going to divide that by 3 again. 12 divided by 3 is 4. And then off to the side, I'll check 111 divided by 3. So 3 goes into 11 3 times to give me 9 with 2 left over. 3 goes into 21 7 times. So I know that 111 divided by 3 is 37. And I've shown that my recurring decimal, which we let be x at the beginning, is equal to 4 over 37. Pause the video and give this question a go. Okay, let's run through it. Let's start in the same way. Let's let x be equal to our recurring decimal. And we have 3 digits that are recurring, so we're going to shift 3 place value columns to the left. We'll find out that 1000x is 345.345 recurring. We can then do 1000x subtract x, and that's going to be equal to 345.345, all of those recurring, subtract 0.345 recurring. 1000x subtract x is 999x, and 345.345 recurring subtract 0.345 recurring is 345. We'll divide both sides by 999. So 345 divided by 999, what x is equal to. And we need to show that this is equal to 115 over 333. I can divide both my numerator and denominator by 3. And I'll check what 345 divided by 3 is. 3 goes into 3 one time, 3 goes into 4 once with 1 left over, and 3 goes into 15 5 times. So x is equal to 345 divided by 3, we said was 115, and 999 divided by 3 is 333. And so I've shown that my recurring decimal is equal to 115 over 33. Our next example has a whole number part at the start. Show that 1.25 with this 5-digit recurring is equal to 113 over 90. Let's start in the exact same way we normally do. Let x be equal to 1.25 with this 5-digit recurring. And because there's only 1 digit recurring, I only need to shift everything 1 place value column to the left. I can say that 10x is equal to 12.555 recurring. And I can see that this tail, the recurring tail, so to speak, is lined up. So I can subtract these. I'll do 10x subtract x, and I'll do 12.555 subtract 1.2555. Off to the side, I'll do my column subtraction. So I'll take my 12.555 and I'll subtract my 1.2555. Both of those, of course, recurring. 5 subtract 5 is 0, 5 subtract 5 is 0, 5 subtract 2 is 3, and 12 subtract 1 is 11. So this calculation gives me an answer of 11.3. 10x subtract x is 9x, and this is equal to 11.3. I'm going to multiply both sides by 10 to remove that decimal point. 9x multiplied by 10 is 90x, and 11.3 multiplied by 10 is 113. Divide both sides by 90. Gives me an answer of x is equal to 113 over 90. And we said x was our recurring decimal, so 1.25 recurring is equal to 113 over 90. Pause the video and give this last question a go. Let's go through it. Show that 5.34 recurring is equal to 481 over 90. We'll say let x be equal to 5.344 recurring. And we only have 1 digit recurring, so we only need to shift everything 1 place value column to the left. 10x is 53.444. Dot, dot. We can then subtract these because our recurring tail lines up at this point. We'll do 10x subtract x. That's going to be equal to 53.44 recurring, subtract 5.3444 recurring. Column subtraction off to the side, 53.44 dot dot dot, subtract 5.3444 dot dot dot. 4 subtract 4 is 0, 4 subtract 3 is 1, and 3 subtract 5 we can't do, so we need to exchange one of our 10s for 10 units. 13 subtract 5 is 8, and that leaves us with 48.1. 10x subtract x is 9x, and we've shown that this right-hand side calculation gives us 48.1. We'll multiply both sides by 10 to get rid of the decimal point on our right-hand side. 9x multiplied by 10 is 90x, and 48.1 multiplied by 10 is 481. My last step is to divide both sides by 90. So I'll just show that. X is equal to 481 over 90. And we said at the beginning that x was our recurring decimal, so our last line could be this: 5.34 recurring is equal to 481 over 90. If you're following along in our lesson booklets, you can pause the video and complete exercises 1 to 3. Thank you for watching this video.